Welcome to solverfy.
Thirteen 13.44, we have a hydraulic piston sort of setup here. So we're told that the diameter of this smaller piston is 2 centimeters. The diameter of this larger piston is 6 centimeters. And so we know from Pascal's principle and the definition of pressure that when we push on this smaller piston with some force, the larger piston can exert a larger force because the change in pressure is the same on the bottom of this piston and on the bottom of this piston because of Pascal's principle. And then the area being the same from the definition of pressure means that there's a greater force that can be exerted by this piston. And so we want to find what the ratio of those two forces is. So the force that is being, let's do 1 first. On 1 is going to be the pressure, or the change in pressure from displacing that, times area 1. So pressure times pi d1 over 2 squared and then similarly the force on 2, the pressure is the same everywhere in the fluid, or the changes in pressure are the same everywhere in the fluid. In this case it doesn't really matter. We can be a bit imprecise. And so this is P times pi times d2 over 2, the radius, squared. And so then the factor by which the larger piston can exert a force compared to the force applied to the smaller piston is P times pi d1, let's just keep it written like this, d1 over 2 squared divided by P times pi times d2 over 2 squared. So the pressures are equal. Pi is hopefully equal to itself. So here we have 1 centimeter squared, because 2 divided by 2 is 1, and then 6 divided by 2 is 3. And squaring that gives us 9 centimeters squared. Oh, I have these backwards. This should be d2 on top. So this should be 9 centimeters squared over 1 centimeter squared, which now makes more sense because the force from 2, since it's larger, should be greater. And so you can exert a force with piston 2 here that's a factor of 9 greater than the force you apply to piston 1.